Okay, let's see. This is 48 degrees here. Right, so we've got a tension acting like this. So hard to draw a diagonal line. It's kind of like Etch-a-Sketch. Okay, so we got the tension. Notice that the tension is going to actually pull this beam to the right, and so therefore the force of the wall will be to the left. Okay, so here's two components of that tension. This is, of course, T sine 48. This side here is T cos 48. Notice that because of this thing's all funky, right? This force is actually to the right. Okay. Then we've got the wall. The wall is, of course, exerting a force upward. And the wall is exerting a force to the right. That'll actually be to the left, but I always do this. I always set it up and to the right. So here's the wall in the y direction. This is the wall in the x direction, right? Then the force of gravity on the beam acts at the center of mass of the beam. So 7g, the beam is 2 meters long. So that's at 1 meter from the left side. Okay, the tension is at, the cable's connected at 1.5 meters, so that's at 1.5 meters is where that's connected, right? And then this guy is at 2 meters from the left side, so we've got a force of, we've got 3g at, how far? 2 meters from the left side. 2.0 meters from the left side. All right. So now let's set up our x direction, right? Okay, in the x direction, we've got the wall in the x direction, right? And then notice that this component's actually to the right, okay? This cable is actually pulling it to the right. So I'm just going to say plus T cos 48. And then, of course, the wall force in the x direction will be negative, and therefore it'll be left. You can set that up however you want. That's how I do it. Okay, and then that's going to be 0. Okay, so this is plus because that component's to the right. Normally it's to the left, but this problem it's to the right. Okay, and then let's set up the y direction. Okay, so in the y direction, we've got the wall in the y direction. Minus 7g plus t sine 48. That's a 4. All right. Let's see. What else? Oh, we got 3g, so minus 3g is 0. All right. And then let's set up our torque. Let's torque about the left side. All right. So the torque is about the left side is 0 times the wall in the y direction. All right, and then we've got a positive torque due to this guy. This guy's going to tend to torque it clockwise, right? So plus 1 meter times 7g. Now the next torque is the cable torquing it anti-clockwise, right? So minus 1.5. The minus is because it's anti-clockwise. The gravity is, of course, torquing it clockwise, right? And then that's T sine 48. Okay, let's see. And then I think there's one more clockwise torque, this guy, right? So plus, how far out? It's 2 meters out because it's a 2 meter long beam. So 2 meters times 3g. And that's 0. All right. And again, you know, we picked that spot so we could get rid of that variable. Now we can solve for the tension. All right, here we go. So I'm going to go 1 times 7 times 9.81 plus 2 times 3 times 9.81. I get a number. I'm going to divide by 1.5. Divide by the sine of 48. 114.4 is the tension. 114.4 newtons. All right, now we can plug that in here, right? So the wall in the x direction plus 114.4 cos 48 is 0. All right, let's do this. Let's see, 114 times cos. And I get that it's negative 76.5, so the wall in the x direction. Newtons, so it's 76.6 newtons left. And you need to say that. You need to say to the left. I'm not just going to accept a minus sign. You have to say left. All right. All right. Now let's do this guy here. All right. Got a busy house over here. Okay, so let's substitute. This is wall in the y direction. Minus 7g plus, and then I can just plug in for the tension, 114.4 sine 48 minus 3g is 0. All right, let's see. Yeah, we can solve that for y. Okay, so the wall in the y direction. Yeah, I don't know. I don't even know which way. It's going to be up or down. Okay. Okay, so let's just do this. So 7 times 9.81 plus 3 times 9.81. And then I guess I subtract that guy. So minus that 114.4 times sine of 48. 13.08. Oh, that's cool. That's a cool number. 0.79 bar, it looks like. I'm not sure, but it looks like it, right? Newtons, the fact that it's positive means that it's up, right? So you'd say 13.1 newtons up. It's interesting. Not much force. There's not much force up, but it is an upward force. Presumably because if we got a heavier box here hung on there, right, it would actually be a downward force. But the fact because it's not heavy enough, and so the weight of the beam has to be supported. All right. I don't know. I love these problems. Maybe you don't love them, but I think they're cool.